So negative 1 plus 14/4. But that's, now you're more complicated, yeah. All right, so we can put that away? Yes? Okay. All right. Make sure you ask any questions, because after this you're going to take a quiz. You're going to do a quiz. What? Can't believe that he would do that to us. I'm going to ask you to graph something. I'm not sure if I'll put a phase shift in. Let's see how you do with this. Okay, what am I going to do?
Set the argument equal to 0 and 2 pi.
0 and 2 pi. Why? That's not cosine, though. Okay, so let's go turn this into a cosine first. Okay, let's do that. We're going to turn this into a cosine first. All right, we're going to do that. Now you set the argument equal to 0 and 2 pi. So I take my argument, 3x minus pi, set it to 0. 3x minus pi, set it equal to 2 pi. What is the solution to the first equation there? X is what? Pi over 3. It's positive pi over 3, right? Because when you move this over, it becomes positive pi, and then you divide by 3. How about over here? X is just pi. Right? So you move this pi over first, that becomes a 3 pi because you're adding pi to both sides. Then you divide by 3, and you just get 3 pi over 3, and the 3's cancel. So you all right with that? Now I'm going to start drawing this. Are you comfortable with which one of those is on the left and right? Yes? Pi over 3 versus pi? Okay, so pi over 3 is somewhere around here. Pi is, I don't know, about right there. Now what? You want to find the middle? Okay. So to find that point, add them and divide by 2. So you should get 4 pi over 3 over 2, which is 4 pi over 6, which is 2 pi over 3. So I got a common denominator. I turned this into 3 pi over 3. Added them up and got 4 pi over 3, and then flipped over and then reduced. Now I'm doing that a little faster perhaps than you would do it, all right? I understand that, but as long as you understand, like you're comfortable that you could get to that. And then what would you like me to do now? I'm just following your orders at this point. Go ahead. What?
So they want to find the midpoint to the other point.
So you want to find the others? Okay, let's get those. So find that one, that one. Add these two together, divide by 2? Okay. Let's do that. So pi over 3 plus 2 pi over 3 all over 2 again. This kind of gets monotonous, huh? Ooh, wow. When we add those together, we get pi on top, don't we? No. 3 pi. 3 pi over 3? Something ain't right. Oh, no, that's a 2 down there. Sorry. Yeah, that's pi up top, 2. So that's just pi over 2. So you put those together, 3 pi over 3, which is just pi, and then divide by 2. So you just pi over 2. That's nice. And the last one. We have to add 2 pi over 3 to pi, and then divide by 2. Have to get a common denominator here. When you do, you should get 5 pi over 3 over 2 over 1, and then flip it. 5 pi over 6. Are you all feeling more comfortable with this, finding the points in the middle? I mean, it's just like anything else. If you continue to do it over and over, you'll get better at it. Okay, so I'm still following orders now. What?
They are X-intercepts.
X-intercepts. Yes, good. Where are they?
The pi over 2 and pi.
Yep. Okay, so remember, since this is a cosine function, we have x-intercepts here and here. And if we go back to the beginning, we should have kind of reminded ourselves that cosine function looks like this. Yes?
How did you get 5 pi over 3?
Right here?
Yeah.
Okay, so this pi is like a pi over 1. And so I need to put a 3 here and a 3 here so that I get the same denominator. And then I do 2 pi plus 3 pi, which gives me 5 pi over the common denominator of 3. Yes? So that's that, and then you flip it and it becomes 5 pi over 6. All right, so I put the x-intercepts. Next, what do you want me to do? Plug in what? Plug in pi over 3 into the original function, because we need to know if it starts out up or down and figure that out, test it out. So, and we're plugging it, I said original, I meant this one. Okay, so I'm going to plug that in over here. So I'm going to go y equals 1/2 cosine of 3 times, and I'm plugging in pi over 3, and then minus pi. So I'm plugging that in. And good things should happen. Oh yeah, you get what? Cosine of what? Cosine is 0. These cancel. You just get pi minus pi is 0. What is cosine of 0? 1. And then you have a 1/2 out front, right? So this is 1/2 times cosine of 0, which is just a half. So that means here I go up a half, like that. And then down here, at this one, I draw negative 1/2. Am I ready? Oh, no, I'm messed up. Not messed up, but I'm not done. What else do I need here? I need one more point, right? Where? At pi, I need to put it where? At a half, positive half. And now I'm going to draw my little thing that looks like that with smiles and frowns. Is that what you want me to do?
Half a frown,
Half frown.
all the way down.
Would you like it? Dashed. Thank you. I'm going to do it dashed. I'm doing it dashed because this is not my final picture. All right, what's next? We're almost there. What's next? Vertical asymptotes, where? At the x-intercepts. So here and here. And now, final picture. Come in with my blue, right? And
So, is where pi over 3 is it just that half of a happy face again?
yep, it's going to be
Half a smile?
half a smile. Kind of just, you're just halfway happy. You're not completely happy.
And then at 2 pi over 3, it's the frown.
Yep, and this is going to go in between that. And then at the pi, you're going to do your left half of the smile. There you go. What do you think? Can you handle that? Does it seem like a lot of steps?
If you have that much drawn, can't you just draw the entire smile in the first half, or do you check?
Well, the question that's being asked right now is, can we just draw this other part, right?
Since you already have it right.
Where do I put the next vertical, though? That would be my concern. Because the y-axis is not your next vertical,
Oh, yeah.
right?
Yeah.
And so you would need to get where that next one is happening.
Right.
which could be a little problematic. You could find it. You could, because all you'd have to know is what's the distance between these two, right? And if you knew the distance between those two, you could move back by that distance and figure out what that is. That's a question mark. And then you could draw your dotted line, and then you could, right?
Right. And for every point that's positive, the same ones are going to be negative, right?
No.
Not always.
So are you saying like negative pi over 2 is going to be a vertical asymptote? No, it won't. See, once you phase shift stuff, things get all whacked. Because look, here's our cosine function, right? Our cosine function is starting at pi over 3 and doing a complete period, right? It got moved. It was over here, right? It got moved over. In fact, let's actually, again, this is not something I like to ask a lot, but what is the period? What is the period, amplitude, period, and phase shift of this cosine function? So what's the amplitude? Half. What's the period? It's always 2 pi over omega, so 2 pi over 3. And then what's our phase shift? It's going to be phi over omega, right? Or phi over omega? What's phi for us? Pi over omega 3, right? Phi is pi, omega is 3. Yes, omega is 3, pi over 3. So do you see that what this is it's a cosine function with an amplitude of 1/2, a period of 2 pi over 3. So the distance between the beginning and the end is 2 pi over 3. But what we've done is we've shifted the entire graph to the right by pi over 3. And do you see it? Pi over 3 got moved over. All right. I'd like for you to work on, let me just make sure today's the 20th. Man, time has just flown by.
That one long problem.
Yeah, this is the end of chapter 7. I would like for you to work on a problem, and here's what I'll do. I'll give you an option. You can work alone with your notes and your book, or you can work with each other without anything but each other. So let's just take a vote. How many of you want to do the group? Okay, who is adamant that they want to work alone with their notes? Okay, so you can work alone with your notes. That's fine. Everyone else, I'll give the option. What?
My notebook's on my phone. Is that okay?
Your what is?
My book.
Oh, you can borrow mine. Okay, so I'm just going to give you one problem to do, because I do want to start talking about the next section. Everybody will turn in their own problem. What I expect to see is a nice graph. Everything labeled, right? All the intercepts labeled, the amplitude, everything's got to be clean. I seriously will have had this happen to me in the past, where I will get a graph on a test that looks like this, which is exactly what the window in the calculator, the graphing calculator, that's a graphing calculator. It's exactly what the window in the graphing calculator is showing the student. So they just type in the function and they give me this crazy looking graph. Okay, I don't want that on the test. I want all the details, everything that we've done here, all right? Okay, so let's do this. Let's do graph y equals -3 cosecant of -2x plus pi over 2. And I will not give you an up and down shift. I'm just going to give you a phase shift and a change in your period. Otherwise, the rest of it's there. If I start, after we turn in the quizzes, if I have time, and I start talking again, remind me to unmute my microphone. All right? All right, let's now. I want to spend the last 8 minutes talking about the next section. So what I'm going to do is, if you have this ready to turn in right now, you can turn it in, and if it's correct, you can get 110. But it has to be ready right now, okay? The other option is that you take it home and bring it back next time, turn it in the beginning of class. You can still get 100, but you can't get 110. All right? No, you have to, it has to be right this second. So anybody want to turn in right now? Anybody else? Okay. The window is closing to turn it in 5, 4, 3, 2, 1. All right, that's it.
We're still gonna make our point.
Okay.
Our stuff look pretty.
Now, please put it away and pay attention to what I'm doing now. We want to start thinking about something for next class. And I don't want to come in and spend 10 minutes doing this when we come back. So I want to just try and remind you about the idea of inverse functions. All right, so let's take an example from college algebra of a function, something like 2x plus 1, and trying to find its inverse. So the idea here is this. If you were to draw a t-table, have this be x and this f of x, I can start plugging in values for x and it's going to spit out values. So if I plug in 0, what will this function spit out? 1, if I plug in 1. 3, if I plug in 2. 5, how about -1? Spits out -1. Okay, so that's just plugging those in for x, that's what comes out. The inverse function is the function that will reverse everything that just happened. So it'll be if we did the t-table for this new inverse function, then here's what should happen. If I plug in 1, what should it spit out? 0. And if I plug in 3, what should it spit out? 1. And if I plug in 5, it'll spit out 2. And -1 will spit out -1. So it basically just sends all these answers back to where they came from. Does that ring a bell a little bit or no? Now, algebraically, I'm going to do this really fast. The way that we did this back here was that what we did is we said, okay, I'm going to call y equals 2x plus 1. Then, out of nowhere, we replaced your y's with x's and your x's with y's. And then you solve for y. And then, so you subtract 1 on both sides. And then you divide by 2. So you get y is x minus 1 over 2. So you're not going to have to do this in here, all right? But I'm trying to remind you, the way you come up with that function in algebra, there was a technique. And so now check it out. If I take this and I plug in 1, what happens? 1 minus 1 is 0. Over 2 is still 0. Plug in 3. 3 minus 1 is 2. 2 over 2 is 1. Plug in 5. 5 minus 1 is 4. 4 divided by 2 is 2. So you see this function basically takes all the answers here back. If I drew this with a picture, here's how I can look at it. The function f has as its domain these numbers here, 0, 1, 2, -1. And then the range of f was 1, 3, 5, -1. The inverse function goes backwards and takes those back to where they came from. Yes? Okay. So we saw that in algebra, college algebra, if we graph this function, so if I graph that, what would that be if I graphed it? What would it look like? a line, right? This looks like y equals mx plus b. So you could find the y-intercept is 1, the slope of the line is 2, and so it would look like that, right? Now, do you remember in college algebra something called the vertical line test? The vertical line test is a test that we use to see whether or not a graph was a function. Do you remember the horizontal line test? The horizontal line test is what you use to see whether or not it has an inverse. So if I draw these lines and I hit it more than one time, it's not a function. If I draw horizontal lines and I hit it more than one time, it does not have an inverse. This one passes both the vertical and horizontal line test, so it's a function that has an inverse. Yes? If I graphed the inverse function, if I graph this one would also be a line. I'd have to rewrite it. I'd have to split it into two fractions like that. But it would give me a y-intercept of -1/2, and the slope would be not quite as steep. So that's what the inverse would look like. But again, the inverse is a function, isn't it? And it would also have an inverse. So what is the inverse of the inverse? The original function, okay? So it's like this one right here, what is its inverse function? It's that one, okay? This one right here, what is its inverse function? It's that one. They undo each other. Now, in college algebra, we ran into some problems. We ran into problems when we changed this function over to something like this, x squared. Now let's talk about why we ran into a problem. Let's plug in some values. How about 0? What would happen? Plug in, what do you get? Okay, plug in 1, you get 1, 2, you get 4. Let's do some negatives. -2, you get 4, right? So if I come over here and I'm sitting here trying to find its inverse, right? And I'm like, okay, what's the inverse of that one? Well, where are you going to have the problem? Where does 0 need to go back to? Okay, where does 1 go back to? 1. Where does 4 go back? It's two different places, right? That's a problem. And graphically, if we graph this parabola, the problem is that it fails the vertical line test? No, it fails the horizontal line test. So this is a function. For every input, there is one output. But it fails the horizontal line test, meaning that when you come back over here, 4 has to go to two different places, right? -2 and +2. And that means that this thing fails to be a function, because you can't have an input go to two outputs. So whenever we look at a graph of something, the horizontal line test was the main test that we used to determine whether or not it had an inverse, right? So this next section, 8.1, is called the inverse function. Well, the inverse of sine, cosine, and tangent. Actually, all 6 have inverses. But that should have you scratching your head. I have 1 minute. Because if I graph the sine function, and I ask you, is it a function? You will say yes. But if I say, does it have an inverse? You should tell me no. But the next section is about the inverse of the sine. So somehow we need to get around this. We need to somehow make it so that it works. I'll give you one last example. I know, I have negative 30 seconds. If I tell you right now sine of some angle is 1, can you tell me what the angle is? So at what angle do I plug into sine to get 1? Pi over 2 would work? So theta could be pi over 2, right? But is that the only answer? It's not, because pi over 2 is up here, right? That's pi over 2. But I could have gone all the way around and come back up. There's actually an infinite number of places. And graphically, it's here. That's right, pi over 2 is where we're at 1, but then it happens here. And at every one of those peaks, I have answers. So that's like the same thing when we had the parabola. If I give you 4, I say, where does it go back to? You had to say 2 and -2. Well, if I say that, hey, what's coming out of sine is 1, you can't send it back to anything because there's an infinite number of things to send it back to. So we will have to have a workaround, all right? We're going to have a workaround for that situation. But that's what next class will be about, all right? Y'all have a good day, and turn in that quiz next time at the beginning of class. If you want to pick up your quizzes, I have them up here. This is everything I have is graded. I also have some old exams. I have Naomi, Carrie Jo, and that's it. Any Naomi or Carrie Jo, or Corey Jo? Sorry. Carrie Jo?
Did you do the sign?
I didn't do the sign-in sheet. It's all right.
Naomi.
Right here? Okay. Oh, those are from today. Hold on. Those are from today. And he's got the pack. Let me take some of them. I'll just call out some names here. Eric Pena, Brandon Garza, Brandon, Daniela, Eric, Daniela, Michelle Williams, okay, and let's see, Margie, and that's you right there, Mackenzie.
Me.
Daniela? Yes? It's you? Okay, Antonio, Jason, Lexi,
I think I have one more in here somewhere.
Corey Jo,
Should just be
Pablo, Corey Jo, Margie, Alexis, Michelle Williams. What's wrong?
I don't know what I did wrong here.